Great, that's good.
Now you got to watch what you say.
Yeah, okay.
Now it counts.
Now it counts. Everything counts because we're live streaming. Welcome again, day one of JEC 2026. Just checking our audio settings. We're all good, so everyone should be able to hear us. I have joining me today is Johannes Mandler and Elias Hirschbichler.
Exactly.
Is that close enough?
That's very close.
Of Fibionic.
Yes.
Yeah.
Joining me. Happy to have both of these gentlemen joining me on the podcast today. We're going to be talking about their technology. They are a Startup Booster finalist this year.
Yeah.
And very interesting technology. We're going to be highlighting. You can find them at Hall 5N32. Fibionic's nature-inspired FFP. Fibionic fiber placement is the world's fastest fiber placement process. It uses fibers only where needed, produces zero waste, and enables strong, lightweight, cost-efficient composites, sustainable and scalable for mass production, setting a new industry standard. So, again, welcome to the show, and tell us a little bit about the technology.
Yes, maybe I start.
Yes. Elias,
Yeah.
start us out.
Yeah. You already mentioned that we invented the FFP
Yes.
technology, so the world's fastest fiber placement. What is important to mention is that we are basically using as design principle, we are using a bionic design principle.
Okay.
That means we have a look at nature and how nature is building up structures, and namely by placing reinforcement according to the load path, as you can see it on the example of a dragon wings fly, for instance.
Yeah.
And we transfer this so-called bionic design to technical parts,
Yes.
making them stronger and lighter by placing materials such as carbon endless fibers or glass endless fibers according to the load path.
Okay.
And now, as you already mentioned, the real breakthrough comes when combining this bionic design principle with this world's fastest fiber placement, our FFP process. So that is the real game changer for mass production. We bring, let's say, the advantages of bionic design to the mass.
Wow. And the cost saving, so you say you're only placing where it's needed, in the areas needed on the
Exactly.
part. So it's much more efficient. I mean, is that part of the streamlining and the speed? Is that you're targeting only the specific areas where needed?
Exactly. So we put the reinforcements only where the loads occur.
Yeah.
That means we can save a lot of reinforcement material. We can make the products much lighter.
Yeah.
In the end, save a lot of costs.
Yeah.
And what is important, as you mentioned, the speed.
Speed.
So because it makes it, for the first time, even possible to manufacture these composite structures in high volumes. Yeah.
So that was one of our biggest goals, to bring
Yeah.
composites to mass production and to high volume products. Not
Yeah.
only like the most valuable 5 Lamborghinis built a year, but to really all day products like a bicycle seller.
Yeah. So talk about some of the applications or some industries that you're seeing success in right now with this.
Yeah, so our beachhead market is the sports and the leisure market,
Okay.
where we now have several projects in the field of bicycle components,
Mhm.
but we also have first projects in the field of drone propellers and drone bodies, and we have
Which is
also
a huge industry
yeah,
right
it's
now.
a huge industry. Everything is growing,
Yeah.
and there's also a huge impact of our technology because we enable them to produce higher volumes than now with their standard production processes using RTM or pre-break composite materials. And from there on, we also tackle the wearables and electronics market because everything you wear, every component you carry, you want it to be as light as possible.
Sure.
And there are really, really high numbers. So they are looking for new production technologies which enable the scaling.
Okay. What is this? Is this a...
This is actually the first product which is already in serious production.
Okay.
So it's a bicycle reinforcement structure,
Okay.
which we developed together with the company Selle Italia. We also will showcase that at our booth here you can see, let's say the final product with our inlay structure. In this case, we could save a lot of weight, 25%, by simultaneously increasing the performance of the product.
And this is what type? This is a bicycle?
That's a bicycle saddle, yeah.
Okay. Oh yeah, I see the saddle.
Yeah.
And
It's a shell, yeah.
A 25% weight reduction. That means a lot.
Yeah.
When the overall weight of the bicycle, when you're factoring everything in.
It does, and moreover, we managed to reduce the weight by 25%, as you said, and our structure also has a huge impact on durability. Because using these endless carbon fibers, taking all the loads also prevents the plastic injection molded material from creeping.
Right. So let me see.
Yeah.
Let me
sure.
Check the two. It's amazing.
Yeah, maybe in general, so our sweet spot are really shallow-shaped composite structures produced in high volumes.
Okay.
So as we can see it here on the example of a bicycle saddle, Johannes mentioned many other applications, so it's transferable across multiple industries. You're starting from sports and leisure, going to the drone segment, ending up in the aerospace and automotive industry. So that's our sweet spot, in the end.
So a part like that, for if you talk about speed, what on average for a part like this to be?
We aim for production cycles of 1 minute per reinforcement structure per fiber skeleton, and this combines perfectly, for example, with the injection molding process, since we do have here cycle times of around about 1 minute as well.
Right. So going back to, because I notice a lot of companies right now are taking a lot of principles from nature, and integrating that. So go back to that discussion. What exactly from nature inspired you to? This whole design, right?
Yeah. So maybe I think also at this point we send out greetings to Thomas Reddenwander. So he's our third founder.
Sure. Yeah.
And thermoplastic expert.
Yeah.
And he somehow was dealing with this question: how can we build up the optimized structures?
Okay.
And he quickly came to this bionic design approach, because nature, as I mentioned, already shows us how to build up structures. Yeah.
Sure.
So like the wing of a dragonfly, you can see the reinforcements only when needed, and at the other parts you can basically save the material and make it lighter by simultaneously have the same performance in the end.
So how does this design approach, you've already mentioned how it improves weight performance, material efficiency, but compared to traditional layups, I think you've mentioned that it's faster.
It's faster and it's much more resource saving, since we really try to use minimum fiber content to keep the costs low, and also to keep sustainability high. And this brings me to another point: since we are only using thermoplastic matrix systems, our products are fully recyclable. For example, here in the bicycle saddle, we're using here carbon endless fibers with a PA12 matrix. We are using PA12 with short carbon fibers as injection molding material, which means if you shred the component after it's not used anymore, you again receive injection molding material. So you receive PA12 with short carbon fibers. You can reuse it.
And maybe to sum it up, so we always compare ourselves with, on the other side, robot-based laying systems.
Right.
As already mentioned, they are very precise but much slower. And on the other side, we have thermoforming and stamping methods, which can be slow, but which can be fast. Sorry, but need much more material as our process. And in the end, we combine the best of both worlds. We say. So the precision and the speed with our tool-based Airstream technology.
So you showed us the bicycle seat. What are some other opportunities, or maybe some of the biggest opportunities you see for this technology, whether it's automotive, aerospace? Where do you see this moving into for many of your clients?
As we already said, it's the next step. We are tackling the UAV and drone sector.
Yeah, that's right.
But also electronic and wearable devices. So using AR or VR glasses, you want them to be as light as possible. That's also huge numbers and a very big application of the future.
Right.
And the cool thing is that we can even bring more advantages to the product, not only reducing weight, increasing performance, but also, for example, using pitch-based fibers would enable us to make structures that are capable of transferring heat, for example.
I've got, I want to showcase once again, just so people that are watching can get an idea of your process. I mean, look at that.
Yeah, so instead of some kind of mechanical robot or something placing roving by roving, we managed to place all the rovings in parallel, and therefore reducing the production speed by factor up to 50.
Up to 50, wow. I have Hall 5 N32. That's where your partner is right now.
Yeah.
So he's manning the booth, hopefully while you guys are here.
Actually, Thomas is really in production at home, so he's testing out a lot of stuff.
So he's doing real work, right?
He's doing the real work.
Yeah.
But one of our colleagues, one of our employees, at the
very good
booth. Yeah.
So hopefully they're meeting a lot of people at the booth right now as we speak.
Yeah.
And Thomas is back in home in Austria. That's where you guys are based out of, right?
Yes, exactly.
Austria. A beautiful area, by the way. And so he's doing a lot of the. So tell us, how did this partnership form? In the beginning.
So maybe
Go ahead,
I
Johannes.
can explain it since I know Thomas for a long time, also on a private basis, and I always followed his work during his PhD.
Okay.
And after he's finished his thesis, he showed me the results, and he told me, look, how much opportunities this bionic design approach would offer.
Yeah.
And there's even some customers who want this kind of stuff,
Yeah.
but there's this big gap about this production technology. And then we found together in the regular brainstorming sessions and stuff.
Sure.
So my background is mechatronics, and together we then developed this kind of process that we call FFP, fibionic fiber placement.
Yeah.
And I joined later on, so I'm the guy, the non-tech guy. So I'm coming from the business perspective.
Okay.
And that's how I would say we are a very heterogeneous team at the end. So we have Thomas as a thermoplastic expert, we have Johannes as a mechatronic expert, and myself who's covering the business related.
The business side of it.
The business side of it,
Business development, which
exactly
is very important, right? I mean, that's everybody plays a crucial role in your organization.
Sure.
So how big's your team total right now as you're growing?
Yeah, actually, we received or we could close a funding round by the end of last year.
Yes.
So our seed funding round, we're very happy with our investors on board now.
That's fantastic.
And we could grow our team already. So now we are 9 employees, and 3 of us. So in total we are 12.
12.
We are constantly, let's say, searching for new motivated employees.
That's right.
Who want to shape the future of lightweight manufacturing. So we are always open.
Will we be seeing this technology in the States soon?
Yeah, we hope so, of course. So we also have US American customers, and maybe a word to our business model, since Fibionic is offering the whole ecosystem that you need to develop and produce this kind of structures. So we are offering prototyping services and also the development services.
Right.
We are offering our in-house production with a free capacity now of around about 150 parts, 150,000 parts, of course. And at the end of the day, in around about 1.5 years, we want to start our solution sales, which means providing our customers with the software, with the prototyping equipment, as well as the serious production equipment and the input material. Okay. So everyone can use fibionics technology to produce and develop their own parts. Since we want to set a new industry standard,
Absolutely.
we said we have to sell the equipment
Yeah.
and enable our partners, enable our customers to use the technology.
Yeah, that's fantastic. And support them with the obviously the training and everything that goes with
Yeah.
it.
So in the end, from a long perspective, we want to position ourselves as technology provider.
Sure.
So we are ramping up at the moment, developing still the serious production process. But as Johannes said, in the end, we will, let's say, position ourselves as technology provider and developer. Yeah.
Gentlemen, thank you for stopping by. How's the show been so far for you all?
It's fantastic, actually. Yeah. We are very happy to be back at Czech. So this time, as you mentioned, we are, let's say, we have two booths actually. So one at Hall 5 at N32, and we have the other one at the startup booth entrance at Hall 6. So it's great.
Meeting with our friend Yannick. I mean, I guess you have some potential investors here that want to talk to you, maybe, hopefully.
We're always open to discussions.
Always,
yes,
you never know, right?
You never know. And for example, some strategic investors, strategic partners would also be very interesting for us.
Yeah, absolutely. Well, congratulations to both of you.
So
Thank
much,
you for stopping by.
Thank you for having us.
Elias, Johannes, it's been great having you on the podcast today. Best of success for you all at the show the rest today, tomorrow, and Thursday. And best of success moving forward to Fibionic.
Thank you so much.
Thank you very much.
All the best.
Thank you.